Today we will be working on 3-5 and we will be proving lines parallel. Parallel lines can be found almost anywhere, like the railings of a roller coaster or in a bowling alley. The objective of today is to learn how to prove lines parallel. In our previous lesson, we used slopes to identify parallel and perpendicular lines. Now we move on to Chapter 3, Section 5, where we will learn to recognize angle pairs with parallel lines, which will help us prove that two lines are parallel. Some vocabulary terms you may want to know before we begin are a conditional statement. A conditional statement is a statement that can be written in if-then form. An example of a conditional statement may be, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Another vocabulary term you may want to know is converse. A converse is the statement formed by exchanging the hypothesis and conclusion of a conditional statement. An example would be, if I am at McDonald's, then I will get a Big Mac combo with a Sprite and a chocolate chip cookie. The converse of that example would be, if I get a Big Mac combo with a Sprite and a chocolate chip cookie, then I am at McDonald's. We're simply switching the hypothesis and conclusion. Alright, now moving on to the converse of corresponding angles postulate. What this says is, if two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So if you have two lines cut by a transversal and corresponding angles, so in this case, an example would be, if angle 4 is congruent to angle 7, then line N is parallel to line C. This is the converse of corresponding angles postulate. Now remember, the corresponding angles postulate just said if you had two lines that are parallel cut by a transversal, then the corresponding angles are congruent. Now this is saying if you have two lines that you don't know are parallel, but you do know that the corresponding angles are congruent, then the lines are parallel. Then as another example, you could use angle 6 and angle 3. If angle 6 is congruent to angle 3, then you know for a fact that line N is parallel to line C. Now moving on to the parallel postulate. It's very simple. If given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. And there's a diagram as an example. Now the alternate exterior angles converse theorem, which is similar to the others, but it's just the exterior angles this time. Where it says if two lines in a plane are cut by a transversal so that each pair of alternate exterior angles are congruent, then the lines are parallel. An example would be if angle 4 is congruent to angle 6, then line M is parallel to line L. Now the consecutive interior angles converse theorem says that if two lines in a plane are cut by a transversal so that a pair of consecutive interior angles are supplementary, then the lines are parallel. So for example, if angle ABF plus angle EFB equals 180 degrees, then segment AC is parallel to segment EG. Another example would be if angle CBF plus angle GFB equals 180 degrees, then segment AC is parallel to segment EG. Now the alternate interior angles converse theorem very similarly puts if two lines in a plane are cut by a transversal so that each pair of alternate interior angles are congruent, then the lines are parallel. An example would be if angle 3 is congruent to angle 6, then line M is parallel to line L. As it would be the same if angle 4 is congruent to angle 5, then line M would still be parallel to line L. Now the perpendicular transversal converse says that in a plane, if two lines are perpendicular to the same line, then they are parallel. An example would be if the given line K is perpendicular to the line T, and line L is perpendicular to line T as well, then line K is parallel to line L. Now that we know all of the theorems and postulates, we may continue on to our first example. Given the following information, determine if line L is parallel to line M. State the postulate or theorem that justifies your answer. So part A says that we're looking at angle 2 and angle 5. These are actually vertical angles, and there is no theorem that proves these lines parallel. So no, vertical angles don't prove lines parallel. there just isn't enough information. Next, we're looking at angle 8 and angle 2. These are alternate interior angles, and we know that because they're congruent to each other. So yes, by alternate interior angle converse theorem, this proves that line L is parallel to line M. And now we're looking at our last pair of angles, angle 4 and angle 7. These are corresponding angles, so yes, they do prove line L is parallel to line M by the converse of corresponding angles postulate. So now moving on to our second example, we're going to solve for x so that line J is parallel to line K. So what we would have to do in order to make line J parallel to line K is make these alternate interior angles equal. So the first thing we're going to do is just make them equal over here. Subtract 7 on both sides. Then subtract 20 on both sides, which will give us that difference. And then we're going to divide by -2 on both sides, which will then give us x equals 8. Now that we've found x and that it equals 8, we know that the degrees on these alternate interior angles equals 60 degrees, which makes line J parallel to line K. And that's it for 3-5. Thanks for watching.